The title of this note is Function Operations, and the outcome is to be able to evaluate a composite function. So function operations, there are 4 basic operations. Just like with numbers, how you can add, subtract, multiply, and divide, you can do the same thing with functions. So here's the 4 operations, and you need to be familiar with both forms of function notation. So if the notation says f plus g of x, that's how that's read. F plus g of x. Anytime there's parentheses, it's the word of. That is the same thing as saying f of x plus g of x. And so on and so on. So this says f minus g of x is the same thing as taking f of x minus g of x. F times g is the same thing as f of x times g of x. And then the quotient, which is division, f divided by g of x is the same thing as f of x divided by g of x. So what is this actually going to look like when you're doing a problem? So you're going to be given a couple different functions. So here we have 4 functions. We have f, which is an equation, g, which is a table, h is a graph, and j is another equation. You do not need to write any of this stuff above the green line. But what I want you to watch is how we're going to solve these. So f plus g of 3. To solve that, we will do f of 3 minus g of 3. Because that's coming off, oops, sorry, that should be plus. That's coming off of the last page, right? That's the definition of addition, is that you can separate the 2 functions. So that's all that I did there. I just separated the 2 functions. And now I'm going to solve. So f of 3, to find f of 3, I can substitute 3 into this equation. And so 3 times 3 plus 2, which would be 11. Plus, and then to find g of 3, I'm going to go to the table. And so the output of g when the input is 3 is negative 5. And then I would sum these together. I would add them together. 11 minus 5 is 6. Moving to the next one, f of x minus j of x. This time you're doing a function operation and there is no value. So the input is just an x. So what you want is an equation at the end. So f of x is 3x plus 2 minus all of j of x, which is x cubed. And then you're just going to simplify as much as possible. We like to write polynomials in standard form with the highest degree first. So negative x cubed plus 3x plus 2. You do whatever algebra you know how to do to simplify as much as possible. All right, so a couple more examples on this page. So we have an example of addition. So not of addition, of multiplication. G times h of negative 1. So again, we can rewrite that. Like that. And we see that g of negative 1, again, going to the table, is negative 3. And h of negative 1, and be very careful here. The input is negative 1, so you go up to negative 1 on the x-axis, and then you go up. And it looks like there's 2 points there. We need the one that is filled in. So the output at negative 1 is 2. So h of negative 1 is 2. All right, and then the last one is division. That's what it should look like. So we have h divided by j of 2. Again, that's the same thing as saying h of 2 divided by j of 2. So h of 2, again, I'm reading off the table. I'm going over to 2, and I'm seeing that the output is at negative 1. And then j of 2, I'm going to use this equation, x cubed. 2 cubed is 8. So, and I would simplify if I could, but that's simplified already. So negative 1/8 is the solution there. So that's what your basic operations look like. Now, with function operations, there is actually a 5th operation, which is called composition. So you've seen this before. The notation, there's a couple of different notations. There's this one, which is f of g of x, which is sometimes abbreviated f of g of x. So you might have heard Fogg and Goff last year. And this notation just says the input into f is g of x. And so we have here what we call an outside function and an inside function. So in this case, f is the outside, and G is the inside because it's inside of those parentheses. It's the input for F. So when you have a couple of functions, you have a couple steps. First, you're going to write the outside function using a placeholder notation. So I typically just do a blank line as my placeholder, and I'll show you an example of that. Then you're going to express the function f of g of x. So that just means you're going to put g of x in all of your blanks. That's step 3. And then just like we did with the other operations, when there's an x, you're just going to simplify as much as possible. So let's look at an example. All right, so again, same functions. You don't necessarily need to write them down, but let's find f of j of x. So f of j of x, we want to write the outside function, which is f, using placeholder notation. So the x will be a blank. F of blank equals 3 times blank plus 2. I'm going to move that out of the way. I can even put parentheses there for multiplication. And that's just coming from this equation right there. And all I did was I wrote it using a blank for the x. That's the placeholder notation. And then in the placeholder, I will put j of x. That's going to be the input. And now that I have that in there, I can actually put j of x in there. And I like to color code things to start. So j of x is x cubed. And then lastly, I want to simplify as much as possible. So 3 times x cubed is 3x cubed plus 2. So that is f of j of x. The other scenario you might see is instead of an x, you might have a number. So this example is h of g of 3. So it's going to work much the same way. The input is g of 3. So we're going to use that placeholder notation. And I can see from my table that g of 3 is -5. So all I've done is I've replaced g of 3 with the value 5, which I read off the table. And now I want to solve h of 5. So if I go up to my graph, I need to scroll up so I can see that. So if I go to -5, I see, oh, wait a second, there is no -5 on the graph. So h of -5 doesn't have a solution. So this particular example is undefined. So another way to think of this is 3 is the input into g. This output is -5. And then -5 is input into the h function. It does not have an output, which is why the final answer is undefined. So that's it for our notes. Go ahead and draw your line and bring your notes in for class.